Okay, let's discuss question number 6. You can see that they have given these species to compare, right? The atomic radii. Now, when you go from left to the right across a period, you know that the atomic radius has to decrease. Why does it decrease? Because the effective nuclear charge increases when you go from what? Left to the right. Effective nuclear charge increases because number of protons increase. When you go from left to the right, atomic radius decreases. When you go down a group, right? When you go down a group, what happens? The atomic radius increases because the number of energy levels increase, right? So this is very simple, right? So if you consider neutral atoms and then anions, so we know that anions have a high atomic radius than the neutral atoms, right? Okay, now listen. Sulfur, chlorine, fluorine, oxygen, right? Forget about the anions first. Okay, now general thinking, sulfur, chlorine, fluorine, oxygen, right? Sulfur and chlorine, they belong to what? They belong to the third period, while oxygen and fluorine, they belong to what? The second period, right? Sulfur and chlorine belong to the third period, and oxygen and fluorine belongs to what? The second period. So you know that sulfur and chlorine, they should be having higher atomic radii than what? Oxygen and fluorine. That should be understood. So then we have to compare first sulfur and chlorine. Here specifically what? S2 minus and what? Cl minus. Okay, compare sulfur and S2 minus. What can you say? Sulfur and S2 minus both have the same number of protons, both have the same nucleus, right? Both have the same nucleus. But you know that effective nuclear charge is equal to what? Nuclear charge minus what? Shielding effect. The nuclear charge is same for both, but the shielding effect of what? Sulfide ion is greater. Therefore, what's going to happen? The amount that we subtract is going to be greater. Therefore, what? Effective nuclear charge is going to be what? Less. Is that clear? I hope you understood that point. All right. Now listen. If the effective nuclear charge decreases, the attraction of electrons towards the nucleus decreases. Then what happens? Atomic radius decreases. Right. Then you can understand sulfide ion has a higher atomic radius than what? Sulfur. I'm defining you the theory really quickly. Right. Similarly, Cl minus has what? A higher atomic radius than what? Chlorine. F minus has what? A higher atomic radius than fluorine. O2 minus has what? A higher atomic radius than what? Oxygen. Right. Okay. So listen. Now, sulfide ion and Cl minus ion. Obviously, sulfide ion is having what? A higher atomic radius than what? Cl minus. Yeah. Right. The reason is now sulfur and chlorine. You know, sulfur is found before what? Chlorine. Sulfur, chlorine, argon. No, right? Phosphorus, sulfur, chlorine, argon. So sulfur, chlorine, argon. So what happens when you're going from left to the right? What happens when you go from left to the right? The effective nuclear charge increases, atomic radius decreases. Then the atomic radius of what? Chlorine is less than sulfur, and here sulfur has 2 minus also, no? 2 minus also, and Cl has only 1 minus. So we can understand sulfide ion has higher atomic radius than what? Chloride ion. So from that we can remove answers, no? We can remove 3 and 4. Answers 3 and 4 can be removed because it has Cl minus there, right? So we have 1, 2, and 5. Now listen, oxygen, fluorine. Let's compare oxygen and fluorine. If you compare oxygen and fluorine, now you know fluorine, right, comes like this: nitrogen, oxygen, fluorine, neon, right? When you go from left to the right, what happens? Effective nuclear charge. What happens to effective nuclear charge when you go from left to the right? Yeah, it increases. Then what happens? The atomic radius decreases. Then what can you say? The atomic radius of what? Fluorine should be what? Less than that of oxygen. Then the least atomic radius here out of all these species is going to be what? Fluorine. Definitely. Why? Fluorine should have the least atomic radius because it doesn't even have what? A minus charge, right? And it should be having what? A lower atomic radius than oxygen. So then least should be for what? Fluorine. So from that we can remove what? The second answer. So we removed second, third, and fourth. Then we have to compare what? 1 and 5 only, right? Compare 1 and 5 only. Now listen. Okay, if you compare 1 and 5, you know, where can oxygen be? Where should oxygen be? Oxygen should be what? Closer to what? Fluorine. No? That means now if you compare S2 minus, now this is the order. S2 minus, then Cl minus, then what? O2 minus, F minus. and then what? Oxygen, and then what? This is the correct answer, fluorine. Oxygen should be what? Having atomic radius greater than what? Fluorine, not F minus. F minus has what? A higher shielding effect, and it is an anion. Therefore, it has what? A higher atomic radius compared to what? Oxygen. Is that clear? Right. So this is the answer. You can understand this really well. Right. Let's come to what? The seventh question now. A rigid closed container containing N1 moles of an ideal gas at temperature T1 and pressure P1. When an additional amount of the gas was inserted into the container, the new temperature and pressure were T2 and P2 respectively. The total number of moles of the gas now in the container is, that's a very easy question, right? Okay, now initially we have the temperature T1, pressure P1, number of moles N1. Okay, after adding a certain amount of moles, right? We're adding a certain amount of moles. Then what happens? The pressure becomes P2, temperature becomes T2, and the new number of moles is what? N2. So N2 means what? N1 plus delta N. Is that clear? Right. So this is the final system. This is the initial system. So I can apply PV equals nRT to this first system, right? PV is equal to what? nRT. What's the initial number of moles? N1 equal to PV divided by what? RT, which is equal to what? P1 volume is V divided by what? R, then T1. Right. You know the same volume is there. We have not changed the volume. And R is the universal gas constant. It doesn't change as well. So similarly, in the same way, I can write what? N2. N2 is equal to what? P2V R T2, right? Now listen, I can isolate the term V over R. Okay, I can isolate the term V over R. What is V over R equal to? V over R is equal to what? N1 T1 divided by what? P1 is equal to what? V over R. So V over R is equal to what? N1 T1 over P1. So I can substitute it here. Then I can say N2 is equal to what? P2 over T2 times what? V over R. What is V over R equal to? N1 T1 over what? P1. N1 T1 over what? P1. Is that clear? Right. Then N1 T1 times P2 divided by what? T2 times P1. The answer is what? The second one. Very easy, right? Okay, look at the 8th question now. The total number of electrons exchanged in the reaction of the oxidation of ethanol to acetic acid using acidic dichromate solution, potassium dichromate solution. Now let's see. Right, so they're asking the amount of electrons exchanged, right? It's a pretty easy question. Now let's see this slowly. You know, ethanol, it becomes what? C2H4, C2H5OH, it becomes acetic acid, which is CH3, C11OH. And here dichromate, right? Ions, I can take dichromate ions here. It becomes what? 2 Cr3 plus ions. I'm not going to write water or anything because it's not necessary for the MCQ. You're not balancing this for an essay, right? I'm just taking the oxidation numbers of the relevant species. Now let's see. Here I have to compare the carbon that's oxidized. Let's expand the structure C2H5OH. How does it look like? C2H5OH. Okay, CH3 CH2OH. CH3 CH2OH. I can write it like this, right? CH3 CHHOH. This becomes what? CH3, which I can write like this, CHHH C double bond O OH. That clear? Nothing has happened to this group, CH3, nothing has happened. But we have to compare this carbon then. What's the oxidation number of this carbon? What's the oxidation number of this carbon? Now this carbon is attached directly to this carbon. This carbon is attached directly to this carbon. Therefore, it has no what? Deliverance of oxidation numbers, because carbon-carbon, there's no electronegativity difference. But this carbon is attached to this hydrogen. Hydrogen has a low electronegativity compared to carbon. Then hydrogen gets positive and carbon gets negative, positive one and negative one. Due to this hydrogen, it gets what? -1. This hydrogen gets +1. Due to this oxygen, carbon gets +1 because electronegativity of oxygen is greater than carbon. Then overall oxidation number of this carbon is going to be what? -1, right? Because +1 -1 cancels and then -1 is remaining. What about this carbon? This carbon has what? Okay, it has one double bond. This carbon has one double bond connected to oxygen. Then due to the two bonds here, carbon gets what? +2, and due to oxygen here connected with a single bond, it gets another +1, then it gets +3, and carbon is attached to carbon, therefore no deliverance of oxidation numbers. Then here I have what? +3. Then the difference in oxidation numbers is going to be what? 4 electrons, right? Difference is going to be 4 electrons. Now listen, dichromate and then what? Chromium 3 plus ions. Now listen, the oxidation number of what? Chromium, one chromium atom here is going to be what? +6. But I have two such chromium atoms, then it becomes what? +6 times 2. Here I have what? +6. Then the difference is going to be what? 6 electrons. The difference is 6 electrons. No? I have 6 electrons here and 4 electrons here. Now listen, oxidation and reduction reactions, they occur together, right? They occur together. Then electrons released by the oxidation reaction is used for what? The reduction reaction. So now, where's the reduction reaction? Where's reduction reaction? Where has the oxidation number increased? Here the oxidation number has increased, no? -1 to what? +3. It has increased. That means this is the oxidation step. That means electrons are released here. That clear? And look at this one. Here electrons are accepted because the reduction has occurred. Can I give 4 electrons and then invite Cr2O72- to become Cr3+? No. Can I give fractions of electrons? No, because we are considering a mole here. Okay, now listen. Then obviously I should multiply this by what? 3 and this by 2. Now you get the idea. If I have 12 electrons here, yeah, it can have 12 electrons here. If I release 12 electrons, it can accept what? 12 electrons. So this is the method, right? It's a good question. Okay, now look at the 9th question. The compound of the following, which of the following compounds can undergo aldol condensation when reacted with aqueous sodium hydroxide? Now let's see that. It's a very easy question again, right? Now look at this. Look at the 4th compound. I'll explain. CH3 C H H C double bond O H is the 4th compound. This is what? What is this carbon called? This carbon is called what? Carbonyl carbon. The carbonyl group. This carbon is called what? Carbonyl carbon. This has delta positive, this has delta negative because electronegativity of oxygen is greater than carbon. That clear? Now look at this. What we can see is this carbon and this carbon. What's the relationship? Now this carbon is attached to what? Hydrogen. This is the carbonyl carbon, but this is a normal carbon. But this carbon is attached to what? Hydrogen. This carbon is attached to hydrogen. So we say alpha hydrogen is the hydrogen attached to the carbon, directly attached to what? The carbonyl carbon. Hydrogen attached to the carbon, directly attached to what? The carbonyl carbon. The carbonyl carbon is here, and then directly attached to that is this carbon. This carbon is called what? Alpha carbon. So alpha carbon and then what? Alpha hydrogen. This alpha hydrogen is contributing to acidity, right? We'll talk about these theories in depth later under organic chemistry, right? Okay, now listen. So I have an alpha hydrogen here and alpha hydrogen here. If I have something like this, carbon, oxygen, okay, carbon, 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 hydrogen. Right? Are these alpha carbons and alpha hydrogens? No, because okay, I have a carbon directly attached to carbon, but that directly attached carbon doesn't have a hydrogen directly attached to it. Is that clear? So the qualification is I should have a carbon directly attached to the carbonyl carbon, but that carbon should definitely be having at least one hydrogen atom directly attached to it. I hope you can understand. So yeah, so you can look at structures like, for example, structure, right? Structure number 2, right? Structure number 2, then 3. You can see that this is not the condition, right? So it's very clear. So you should have alpha hydrogen attached to what? Alpha carbon, right? Okay. So if you look at the structure 4, you can see that it has alpha hydrogen. Therefore, it can undergo what? Aldol condensation. Another feature of undergoing aldol condensation is this should be an aldehyde. Exactly. This cannot be what? A carboxylic acid. That's why first stance is wrong, because it is not a carboxylic acid. We have to consider what? Aldehydes for aldol condensation. Right. Now let's see. 10th question. AX solid, A2. Okay. Now we have question number 10. AX solid, A2Y solid, and AZ solids are sparingly soluble salts in water having Ksp values that they have given. Which of the following shows the order of 3 saturated solutions of these salts in decreasing concentration of cation A+. So they're asking for the decreasing concentration of the cation A+. This word decreasing is really important because in the exam time, sometimes you may see the word decreasing as increasing. It has happened. And then you come after writing the exam and say, oh my goodness, I saw the word decreasing as increasing. So this has happened so many times to me. So please be careful, right? Just note down these words, highlight them, right? Incorrect statement, correct statement. These are the small common errors that we make. We don't even care about them, but we have to give a lot of importance to them. We may lose full marks, right? Okay, now listen. I have what? AX solid. It becomes what? A plus A equals plus what? X minus A equals, right? So if we have the precipitate AX solid, I have a saturated solution containing what? A plus A equals ions and what? X minus A equals ions, and there's an equilibrium between them, right? Okay, now let's see. So I can write Ksp like this. So Ksp is equal to what? A plus A equals concentration times what? X minus A equals concentration. The solubility is S, is S, right? Stoichiometry is 1 and 1. So I can say Ksp is equal to what then? S squared, no? So S squared is equal to what? Ksp. Alright, now let me know. What's the Ksp value of AX solid? What's the Ksp value of AX solid? Yeah, 1.6 times 10 to minus 9. That means 16 times 10 to minus 10. So 16 times 10 to minus 10 is equal to what? S squared. Then what is S equal to? Square root of what? 16 times 10 to minus 10. Square root of 16 is what? 4. Square root of 10 to minus 10 is what? 10 to minus 5. Then you get what? 4 times what? 10 to the power minus 5 to be the concentration of what? A plus A equals, because solubility is equal to concentration here, right? It's not always equal, but here S is equal to concentration of what? A plus A equals. If it's 2S, if it's 2A plus, it's going to be what? 2S, right? We'll talk about that later. So here, as we have S for what? The concentration of A plus A equals, the concentration of A plus A equals is going to be equal to what? 4 times 10 to the minus 5 mole per decimeter cube. I represented that with capital M, right? Okay. So we'll note it down now. Here we have what? You consider AX solid, A plus is equal to what? 4 times 10 to the minus 5 M, right? Okay, next. We have what? A 2Y solid. It becomes what? 2A plus A equals and what? Y minus A equals. Now for the ones who are really finding chemistry difficult, I'll explain this. Mg3N2 solid. You look at this. How do you get this? Magnesium 2 plus and what? N3 minus twice, no? Right? So what happens is magnesium and nitride ions you have, this is minus 3, this is what? Plus 2. Then these exchange, right? What's going to happen? It becomes what? Mg3N2. Just like that, we get what? A and Y. So how did A get 2? Because Y had minus 2, right? That clear? Y hat minus 2. Got it? So this is minus 2. Y hat minus 2. Therefore, A should have 1. Is that clear? Right, let's see. So we have what? 2a plus a equals plus what? Y2 minus a equals. Then here we have what? KSP is equal to what? A plus a equals into the power 2, because stoichiometry should be taken as the power, times what? Y2 minus a equals, that's it, right? So KSP is equal to what? I can take the solubility as S. Then if the solubility says 2a plus a equals is going to be what? 2s. This is going to be what? S. Then I have what? 2s to the power 2 times what? S. Then I have what? 4s to the power 3. So 4s to the power 3 is going to be equal to what? KSP. That clear? 4s to the power 3 is equal to what? KSP. Right. Now, we know KSP of what? A2y solid is equal to how much? Yeah, A2y solid, KSP. 3.2 times 10 minus 11. That means what? 32 times 10 minus 12. You can take it like what? 32 times 10 minus 12. That's equal to what? 4 times s to the power 3. Then 32 divided by 4 is what? 8. 8 can be written as what? 2 to the power 3 times what? 10 to the minus 12 means what? 10 to the minus 4 into the power 3. I can have the same power. 10 to the minus 4 into the power 3 is equal to what? S to the power 3. So I'm going to what? Say s is equal to what then? 2 times 10 to the minus 4 into the power 3 and I think 1 over 3 factor. That clear? Then 3 and 3 cancels. Then I have what? S to be equal to what? S is equal to what? 2 times 10 to the minus 4 mole per decimeter cube. Right. Don't select this as the answer because we are finding the concentration of what? A plus A equals cation in the solution. So then A plus A equals cation concentration is going to be equal to what? Twice the solubility. 2s because twice solubility because stoichiometry is what? 2. So solubility is S, and if it's the stoichiometry, if the stoichiometry is 1, the stoichiometry is 1, solubility is equal to what? The concentration. But here, the stoichiometry is 2. Therefore, the concentration of what? A plus A equals is going to be what? Twice the solubility. These are small things that some children, get wrong, right? So now we have the concentration of what? If you consider A2y solid, where the concentration of A plus A equals to be equal to what? Yeah, that's equal to 4 times what? 10 to the minus 4 m. I hope it's clear, right? Right. So next one, we have to consider AZ, right? What happens to AZ? AZ becomes what? A plus A equals plus what? Z minus A equals, no? Very easy. AZ becomes what? A plus A equals plus what? Z minus A equals. So KSP is equal to what? A plus A equals times what? Z minus A equals. Right. What's the KSP value equal to? 9 times 10 minus 12. That is equal to what? S times S. If the solubility is S, right? Then I have what? S squared. S is equal to what? Square root of 9 times 10 minus 12. That means S is equal to what? 3 times what? 10 power minus 4 m. 6 m. That clear? 10 power minus 6 m. Okay. Now see. The lowest is actually the solubility is equal to what? The concentration of what? A plus 2. Right? Because stoichiometry is 1. The lowest concentration for A plus cation is found in what? AZ solid. Highest is found in what? A2y solid. Middle value? AX solid. Exactly. So the answer is going to be equal to what? The second answer, right?